So we're back in our textbook. We're going to go through chapter 12. You probably already figured that out. And chapter 12, section 1 was just plugging in numbers and remembering how to do square roots. That was a pre-algebra idea, but if you need help, just ask. We're going to add and subtract and multiply radicals today. So we are in section 12-2. Sums, differences, and products of radicals. Differences and products of radicals. Okay, so let's talk about simplifying radicals first. Simplifying radicals. And the way I like to think about radicals, and actually we're just going to work with square root. There are other radicals. We might get a chance to talk about them this year, but if not, we will definitely talk about them in Algebra 2. But we're going to work with the square root radical. So if we look at the square root of 72, we're going to simplify this. You are not to use your calculator and get a decimal, okay? So I don't want to see irrational numbers written as rounded decimals or decimals at all. We're going to simplify this we're going to put it in simplest radical form. Simplest radical form. Okay, so 72, we're going to take 72 and we are going to write the prime factorization of 72. So 72, well, it's even, right? So we know that 2 can go into 72. And so 2 goes into 72 how many times? 36. Oh, hey, I've hit a perfect square. If you can identify perfect squares quickly, this is going to go really fast for you. So a perfect square, rather than doing a prime number, I'm going to use a perfect square, so that I can write the square root of 72 as the square root of 2 times 6 times 6. So once you can write a perfect square, do it. Because the square root acts, think of it as a 2 for the price of 1 special. Okay, so here's the store. You can purchase 2 of these numbers if they come in a pair. So they come in a pair of 6. So you can purchase 2 6s, but you only have to pay for 1. So we write on the outside what we paid for. But we can't take the 2 with us because it's a 2 for the price of 1. 2 has to stay. There's not 2 2s. So 2 square root 6 is your simplest radical form. And you will utilize the prime factorization technique until you get to a perfect square. And if you don't get to a perfect square, that's okay. So let's try one. Let's try another one. Let's do the square root of 24. So we're going to write it in simplest radical form. So let's start doing a prime factorization and see if we can find a perfect square. So what goes into 24? Well, I know 2 goes in. That gives me a 12. And what goes into 12? Well, I know 3 goes in. That gives me a 4. Oh, there's perfect square, so that'll be a 2 and a 2. All right, so I can write this as the square root of 24 equals the square root of 2 times 3 times 2 times 2. You can write them in any order, right? Multiplication is commutative. Okay, so let's go shopping. What do we have 2 of? Well, we've got 2 2s. So I can purchase the 2 2s for the price of 1 2. Do I have 2 of anything else? Nope, I don't. I have 1 2 and 1 3. So those are going to have to stay. And go ahead and multiply them together. So simplest radical form is 2 square root of 6. Let's try one more just to see if we've got this. Square root of 18. Write that in simplest radical form. I'm going to give you a chance to give it a try. And actually, you look down at your paper and work, and I'm going to write it out. And then when you're done, you look up, just like we do in class. Okay, so I have 3 square root of 2 because this was my prime factorization, had 2 3's, and so I could take 2 of them home but only pay for 1. And that's what the square root does, is the square root is an operation that says find the perfect squares or the doubles of things. So let's go ahead and do some adding and subtracting and multiplying. So here we go. Let's multiply first. Multiplication is actually a little bit easier. Multiply. We will have the square root of 15 times 7 square root of 20. All right, we can smush it all together, actually. We can write this as the square root of, or pardon me, 7 times the square root of 15 times 20. I am not actually going to multiply 15 times 20. I think it will make the problem harder. But I am going to do the prime factorization of 15 and 20. So I can rewrite this as 7 square root of, we're just doing the prime factorization of what's inside the radical. Does anybody remember what that's called? The radicand? Okay, here we go. 15 is 3 times 5. 20 is 5 times 4, but 4 can be written as 2 and 2. Oh my gosh, my stomach is growling. Isn't that funny how our bodies are still on school meal times? Okay, here we go. 2. Do we have 2 of anything? Yes, we have 2 5s. So I can rewrite. Don't forget your 7 stays out there, but now a 5 is going to join him, and a 2 will join him. And what do we have left? Just the 3. So you can multiply everything on the outside, just like you can multiply everything on the inside of the radical. So 35 and 2 is 70 square root of 3. All right. That's multiplication. Let's do some addition and subtraction. So I'm just going to write the term simplify. So simplify in this case means condense your, not yours, they don't belong to you. Condense the radicals where possible. All right, so simplify in this case is going to mean condense the radicals where possible. So we have 4 square root of 6 minus 7 square root of 6 plus square root of 6. So look at your radicands, the square roots of 6. Are those simplified, first of all? Can you simplify square root of 6 any further? Well, we'd have a 2 times 3, so there's no doubles inside of 6. So we're going to leave that alone. When we add and subtract, you can only add and subtract like radicals. These are all like radicals because they have the square root of 6. So we have 4 square roots of 6 minus 7 square roots of 6. How many square roots of 6 is that? That's negative 3 square roots of 6. So we have negative 3 square roots of 6, this condensed to 1, plus, remember there's the imaginary 1, there's always the 1 there, so negative 3 square roots of 6 plus 1 square root of 6 gives us negative 2 square roots of 6. So we were able to take 3 square roots, and because they were all like square roots, we could condense them into 1 square root. Okay, last example. We are going to simplify, and again, we're going to condense this as best we can. Square root of 75 plus square root of 48. So take a look. We can only condense like radicals. 75 and 48 are not like radicals, so we need to simplify them first. So let's take our square root of 75 and simplify square root of 75. 75 breaks down, well, 5 goes in. Actually, you know what? 3 goes in. I'm going to do 3 first. 3 goes in 25 times because I like that because 25 then goes to 5 and 5. So 75 I can rewrite as 3 times 5 times 5 plus 48. Well, let's see. I know 2 goes in, so that's a 24. 2 goes in again, that's a 12. 3, that's a 4, so that's a 2 and a 2. All right, so I can rewrite this as, I could either write it as 3 times 4 times 4, or I can do 2 times 2 times 3 times 2 times 2. I think I will do 3 times 4 times 4. But that's because I took this set of 2's and combined them and this set of 2's and combined them. And they're the same thing. So now that I'm looking for doubles, 5 square root 3 plus 4 square root of 3. Okay, now do I have like radicals? Check. So 5 square roots of 3 plus 4 square roots of 3 give me 7 square roots of 3. Okay. If this was confusing to you, these 4s, we can talk about it in our Zoom. All right, so that's what section 2 is all about. And guess what? So is section 3 is going to be very similar to this, but we're going to divide. So let's leave that for another day. We'll just do section 2 on this this day, and then we'll do section 3. If you want to go ahead of me, you can, but dividing is similar, but there's a little trick to it. So I will see you in our Zoom.